All right, let's talk about the beautifully chaotic world of Looney Tunes. Anvils appearing out of thin air, tunnels you can paint on a rock wall and then run right through. It's a universe that seems to just laugh in the face of physics. But what if I told you that it doesn't? What if it's all part of a plan?
Seriously, what if underneath all that zany, explosive action, there's actually a hidden set of physical laws? A system that's surprisingly consistent. And get this, what if that system is so robust that it could actually help us understand some of the deepest, most complicated ideas in our very own universe? So, where do we even start trying to find these rules? Well, let's go with the classic, the one we've all seen a million times. Wile E. Coyote running at full speed straight off a cliff.
Now, here's the thing. That moment where he just hangs there in midair, that's not random. It's not just a gag, it's a rule. The paper this is all based on actually gives it a name, delayed gravitation. It happens every single time, and the fall is always triggered by the moment of realization.
Okay, think about it like this. In the Looney Tunes world, gravity is literally powered by awareness. The force only kicks in when a character knows they should be falling. It's kind of like a weird nod to quantum mechanics, right? Before Wile E. Coyote looks down, he's in this strange limbo state. He's both falling and not falling at the same time. That panicked little glance downwards is the observation that collapses the possibilities and makes the fall suddenly and very irreversibly real.
And it doesn't stop with gravity. This universe has a whole system of its own physical laws. You've got hammer space, that magical, invisible place where all the anvils and mallets come from. You've got character regeneration, which is basically the secret to cartoon immortality. And then there's environmental confinement, the rule that says, nope, you guys are stuck in the desert forever. The main takeaway here is, this isn't just chaos, it's a completely different kind of order.
So, we've established that the Looney Tunes universe has its own set of rules. Cool. But the rabbit hole goes so much deeper. What if that endless chase through the desert isn't just about a hungry predator and his prey? What if it's actually a perfect metaphor for the strong nuclear force? The fundamental force that holds the entire universe together.
First, let's do a super quick physics primer. Inside the teeny, tiny, high-energy world of particle physics, there's this state called asymptotic freedom. You can think of it as a place where quarks and gluons can just zip around totally free, barely interacting with the forces that would normally keep them locked down.
And then you have the exact opposite, confinement. This is what happens when you try to pull quarks apart. The force between them gets stronger and stronger the farther apart they get, kind of like a cosmic rubber band you can never snap. They are permanently, inescapably trapped.
And this is where it all just clicks into place. The Roadrunner, just meeping his way through the desert, barely touching the ground, he's like a free quark in that deconfined state. He's the living embodiment of asymptotic freedom. And Wile E. Coyote, he is confinement. He is completely trapped by the very force he's trying to overcome, forever bound to that chase.
And the source material points out this absolutely genius detail. The Coyote's fanaticism is the entire key. His non-stop obsessive pursuit is a constant feed of energy into the system, and that energy is just like the string tension in quantum physics, that cosmic rubber band we were talking about. The more energy he puts in, the stronger the confining force gets, which guarantees he can never, ever win.
Okay, so the chase itself is a perfect map of particle physics. Mind-blowing. But what about all the gear? The rocket skates, the giant slingshots, the instant boulder pills. Where does all that stuff come from?
Well, that classic ability to pull a giant anvil from behind your back, that's explained by hammer space. Just imagine it's a real parallel dimension, a dark brain that's just jam-packed with all the stuff a cartoon character could ever want. Acme products aren't being manufactured, they're being imported into reality.
And this leads to a really wild comparison. Why do Acme products always backfire so horribly? The theory suggests that their consistent failure is a lot like the behavior of dark matter. The idea is that these products are made from matter from another dimension, so they're fundamentally incompatible with the physics of the Looney Tunes world. They just can't interact properly.
So the guaranteed failure of any Acme product becomes this perfect visual for a real process called hadronization or string breaking. All the potential energy that Wile E. Coyote builds up in his elaborate trap has to go somewhere. So when the device inevitably fails, that energy instantly converts into something new, which, in this case, is usually a puff of smoke and a very, very flat coyote. But of course, it doesn't matter how many times he gets flattened or blown up or falls off a cliff. Wile E. Coyote always bounces back for the next scene totally fine. So, how in the world do we explain cartoon immortality?
Believe it or not, the answer might come from a real, though still unproven theory in physics called supersymmetry. It's this really elegant idea that suggests every single particle we know has a hidden, much heavier partner, sometimes called a sparticle.
So, the Wile E. Coyote we see getting pancaked by a boulder, that's just one half of the picture. His unobserved, super stable, and really heavy superpartner, the Coyote Sino, is basically acting like a cosmic reset button. It always restores him to his original, pre-disaster state, making sure no damage is ever permanent.
And this brings up a brilliant distinction in cartoon physics. Getting flattened is a reversible change of state. The underlying rules of being Wile E. Coyote are still there. But then you have something like the dip from Who Framed Roger Rabbit. That's totally different. It's an agent of irreversible change. It doesn't just mess with a character's shape, it fundamentally dissolves the very laws that make them a toon in the first place, leading to, well, actual thermodynamic death.
When you put it all together, what this shows us is that even the most absurd, ridiculous, and hilarious scenarios can actually be a really powerful lens for understanding our own reality. From quantum gravity and dark matter to supersymmetry, it turns out the Looney Tunes universe isn't just breaking the laws of physics, it might be showing us a whole new set. And that leaves us with one final thought. What other incredible secrets are just hiding in plain sight, waiting to be discovered?